Part 2. Calculate the mass of the C6H7O6Na in milligrams in the low acidity vitamin C tablet. So to get this one right, it's depending on you getting the ratio right for the previous bit of the question. But if you use this value, if you've got this number wrong and you use it in the right way, you're still going to get error carried forward marks. You still won't lose this mark. Now, there is a short way of doing this, but I'm going to try and show the long way to explain where the numbers are coming from. So the amount of work that's going to go into this will be much more than you need for 1 mark, but it'll at least explain where the numbers are coming from. So remember, you've got your relationship up here of for every 1 mole of C6H8O6, there are this many moles of the conjugate base. So we need to figure out then in the mass that we've got calculate the mass in milligrams in the low acidity tablet. Now, if you go back to the beginning of the question, it tells you that a tablet contains a mixture of 300 milligrams of vitamin C and this sodium salt. So we're looking to now sort of just use this ratio, use this relationship to figure out the quantities of the salt in this mixture. Okay, so to start off, then we need to know how many moles of the C6H8O6 we have in our tablet. And then from the relationship with this, we can figure out how many moles of the other one we've got, and then we can figure out the mass. That's the stages that we need to go through. So let's start off with that. So we want to work out the moles of the C6H8O6, which is mass of a molar mass. Now remember, this is 300 milligrams, so in grams, that's going to be 0.3 over the molar mass of this. We worked it out before as 176. That equals 0.0017045. Okay, so now remember, for every 1 mole of this chemical, which just worked out there is 0.708 moles of the conjugate base. So therefore, we can say the moles of the C6H7O6 minus is equal to 0.001745 multiplied by 0.708. Let's move that over a little bit there, we can see it. Okay, because you've got this relationship here. We haven't got 1 mole of it, we've got this many moles, so we're just rearranging it. That gives me 1.26 times 10 to the minus 3. So that's my moles of the C6H7O6 minus. So now I want to work out a mass, so I'll rearrange the equation. Mass is moles times molar mass. So moles, 1.26 times 10 to the minus 3, multiplied by the molar mass of the sodium compound here. So remember, 176 was for the C6H8O6. We've got 1 fewer hydrogens plus 23 for the sodiums. So that's going to be 198, which equals 0.2388 grams. And the question asks for it in milligrams, so obviously there's 1,000 milligrams in a gram, so this is going to become 239 if we round it up milligrams. So essentially, the simplified version of this, all you've done is 0.0708 times by 300, or 300 over 176 times by 198. That's what's on the mark scheme. But by doing this, I've shown you where all those numbers have come from. So hopefully you can understand what's gone on there.